Good morning, evening, or afternoon, whenever you're watching this. We are officially into the fourth week of Algebra 1 class. We're going to be going over standard and slope-intercept form. Just a reminder to you guys, if you guys are watching this video, uh, it's generally a good idea to take a pause after every slide. Every slide is roughly going to be about 15 minutes, but yeah, just a suggestion. But if you can power all the way through, more power to you. Now, moving on. Let's look at these are your vocabulary, and yes, you do have to write these down. And for those of you who are writing just the vocabulary in the notes, know that that's not enough. If I just see the vocabulary, um, then it's not, well, okay. Uh, Give me 1 second. All right, so, okay, that has some technical difficulties. Okay, so we're going to be going over these three. Make sure that if you're just writing the vocabulary, make sure you write down the rest of the examples too. Just because I don't, actually say write this down doesn't mean that I don't want you to write it down. If it's in the video, I want you to write it down. You can skip the interpretations if you want, but make sure you write down the problems as well as the examples as well as the vocabulary. For those of you guys who are already doing that, don't worry about it. Just keep doing what you're doing. Now, standard form is a general term meaning written down in the most acceptable way. In Algebra 1, I'm specifically referring to this equation, ax squared plus bx plus c is equal to 0, which is standard form for most equations of the default. Now, that's a standard textbook definition. However, if you look down here, right, I have the examples of the three different formulas that you're going to be using for this lesson. For standard form here, I do have this really weird one. And the only reason I have a square in there, like ax squared plus bx plus c is equal to 0, is because standard form is all about putting things in the correct order. And powers, the higher the power of a term, as in to the second power is a higher power than to the first power, which is a higher power than to a 0 power. It determines the order in which something goes in an equation, usually. And in this case, that's all this version is meant to say. It's just trying to say, like, hey, the ax is squared, therefore it's a higher power, therefore it should be the first term you use all the way to the left. We're reading it from left to right, and left has to have the highest power, followed by the next highest power, which in this case is to the power of 1, right? Which is bx. X has a hidden 1 as the exponent, right? Remember, we usually don't write ones either in the front of the variables or above or below. We don't write any of them, but they're there. They're always there. So this is bx to the power of 1, and plus c. C is just a normal number. There's no x attached to it, right? It technically doesn't have a power, but the whole thing is equal to 0. And this is the 0 there is really important because that's actually where we're going to get our zeros for our coordinate points later on. And it's yeah, it's just gonna be important. I'll explain a little bit more about what that means. But generally speaking, for this week, what you're gonna be dealing with in terms of standard form is gonna be this second equation. Ax plus bx is equal to c, because this is the way the book and the worksheets are gonna present the problems to you. They're gonna present them in this way. They're gonna present them to look like something like, I don't know, 3x plus let's see. So notice how it's a 3x plus I don't know, let's call it 2y or something equals, I don't know, 6. Because that's really all this is representing. This is representing it's a placeholder for values, and the values you're going to get from your problem, and every problem is going to be different. Therefore, every problem is going to have a different equation and different values. So in this case, the c is just a regular number, right? Like 6 is just a normal number. By, right? Y represents a specific something. X represents slope, right? And we'll get into what that means next. So that's the first one, right? Okay, the second one, it says slope-intercept form. The equation of a straight line in the form of y equals mx plus b, where m is slope, right? That's important, of the line, and b is its y-intercept. So what is that referring to? What this is saying is if an equation is in this form and it's y is equal to mx plus b, it's in the form that allows you to graph that equation, right? As long as you know what the slope is, and the slope is m at this point, right? This is your slope, and this is your y-intercept, right? So if you're wondering what a y-intercept is, a y-intercept is just, it's the line in which, uh, it's the point in which your line, the one that we're trying to graph, is going to touch the y-axis. Now remember, the y-axis is the one that's up and down, and the x-axis the one that's left to right. Okay. Okay. So what does that mean? What does the y-intercept mean? Well, if we know that, let's pretend we do know what this is. Our slope is, I don't know. Let's say it's 2x, and let's say our y-intercept is +1. What this means is that the slope of the line is 2/1, right? It's something called rise over run, and this is just regular coordinate point stuff, right? That means that whatever point I am on the line, this 2 means I'm gonna rise 2 spaces above whatever point I'm at, and then I'm going to run 1 space to the right. If there was a negative involved, this was like a -2, I would, instead of going up by 2, I would go down by 2, right? So y-intercept is +1, and that means that at the point 1, wherever 1 is on the y-axis, that's the first point that's going to be on my line. So where it says +1, that means that I need to find +1 on the y-axis, right? If I find +1 on the y-axis and I put a dot there, that's actually what this is referring to. This is referring to the coordinate point 0, 1. Now, I can hear you asking, is there always going to be a 0 in the x part, right? In terms of the y-intercept, yes, right? In terms of the y-intercept, it's always a yes. The x value is always going to be 0 in this case, and the b value is going to be your y value here. Like your, if you notice, this is here, and this is 0. Well, the reason why it says the x is a 0 in this case is because we're only looking for the point in which the line touches the y-axis, and if some if a point is exactly on the y-axis, is exactly on this line right here, right? Then if it's exactly right there, then it's going to have a 0 because it's not touching the x-axis at all, right? It's not touching the the line that's in x. It's not moving to the left, not yet, anyways. In order for the point to move to the left, to the right, it needs a slope. So the slope was 2x, right? And we said that the rise over 1 was 2/1. That means that we're going to move up to 1, 2, and then we're going to move to the right. Remember, because the run is positive, right? We're always going to run to the right, 1. That's going to be our new point. Oops. And that's going to be our new point, and that's how I graph, right? Now, I'm going to go over this a little bit more. I'm just telling you that this is how I use slope-intercept form, and this is what you're going to be doing throughout the entire lesson, right? Now, if we move to the right where it says slope formula, and I have a vocabulary word here, right? I have a vocabulary that says slope. There is a really long dictionary definition for it. Uh, I'm just gonna have you remember it as how steep a line is. So if you look at the line that we just graphed, it's pretty steep, right? It's the line is, it's got a pretty steep slope. Um, but you know, a slope can describe how steep a line is. That's really what it is. The slope formula you're going to use is this: m is equal to y2 minus y1 over x2 minus x1. And what this is, it's essentially just, if I give you 2 coordinate points, you should be able to tell me what the slope of those 2 coordinate points are, kind of like over there. Like over here, right, we have something like 1, 1, 1. Oops, sorry, that's not it. The coordinate point for that first point, remember, as we established, was 0, 1. The coordinate point for that second one, right, is going to be 1, 2. When you have 2 points like that, you can put them into this formula and you can figure out what the slope is. And if I put them in there, I'm going to get 2 because I already know what that is. However, you can do this with any 2 points. You just have to label one of the 2 points. Like if you notice, I have 2 sets here as x1, y1, and your second set of points as x2, y2. Does it matter which one you label as x1 and y1 and which one you label as x2 and y2? No. As long as both of the x and the y's in the same parentheses, in the same point, are 2s or 1s, then it doesn't matter. That just determines order. Like, for example, if I had, let's see, the points 3, 2, and 0, 4 or something, and I wanted to find out the slope, I would plug these in. I'm going to label the first one I see, 3 and 2, as x1 and my y1, and the second one I see as my x2 and y2, and then I'm just going to put them into this formula. So my y2, right, my y2 happens to be 4, so I'm going to put 4. Then minus, the minus is just part of the equation, right? I want to point that out. It's part of the equation. If you have a negative number that you're going to put into y1, you're going to have to put in parentheses because there's going to be 2 negatives. So y1 in this case is positive 2, so I'm going to put in a 2. But because the negative is part of the equation, that makes it a negative 2 now. Okay, x2 is going to be 0, so x2 is 0, minus, because the minus is just part of the equation. Whatever my x1 is, my x1 is 3, 3, right? This is 4 minus 2 is just 2. 0 minus negative 3 is just going to be negative 3. This is going to be negative 2 over 3. I can't seem to write it in there. 2 over 3. Okay. Okay, cool. That was a lot. Copy this down if you haven't, make sure you do. Take a break if you need to, right? And come back for the next part. All right, there's the next part. So creating linear equations in slope-intercept form. These are the kind of problems you're going to have to do. So the problem says, write an equation of each line in slope-intercept form. So where your slope is equal to 3 and the point 2, comma 5 is on the line. So here you have a situation in which you're being asked to create a new equation and that describes the line that has both the slope of 3 or 3 over 1 because it's the rise or run, and the line has to go through 0.25 at some point. Now notice I do have a coordinate point, but that's not my y-intercept. My y-intercept is the exact point in which my line is going to cross the y-axis. That's not what they give us here. The coordinate point that they gave us here is just a point on the line. Could it be that it's my y-intercept? Well, no, because remember, my y-intercept has to have a 0 in the x. And this point is 2 and 5, which means that the first step in order to figure this out, right, is to find out what my y-intercept is. So how do I do that? Well, I'm going to start here. I'm going to start off with slope-intercept form to create an equation. I'm going to just start with the equation y equals mx plus b. For this entire week, you're just always going to start with this equation. You're just going to start with that for the most part. There are some exceptions, but we'll get to that. When you don't know how to start, just start with this equation, right? The next step, right? Step 2, substitute all the terms that you know into the equation. Now, they told us a lot. They told us that our slope, our m, is equal to 3, and they also gave us a coordinate point 2, comma 5. Now, we know that the 2 is going to be an x, and the 5 is going to be a y because that is a coordinate point, essentially. So we know what we know what our x is, we know what our y is, we know what our m is, we don't know what our b is. Remember, our b represents slope, the y-intercept, and that's what we're looking for. So we're going to plug in everything that we know. So the y became the 5, right? Because the y is the 5 here. The m, the slope, is your 3 because they told us that was our slope. We didn't have to figure anything out. They just told us. And our x happens to be 2. So we plugged those in, and the b, we kind of just dropped it. I mean, it's there. We don't know what it is yet, so we're going to solve for it. Using our algebra skills that we've been working on, we're going to have to solve for b using inverse operations to isolate the b, or isolate your y-intercept. So in this case, we just multiplied, right? So 5 is equal to 3 times 2 plus b. 3 times 2 is 6, which is where this came from, right? Okay, so 5 is equal to 6 plus b. At this point, we need to get rid of 6 so that b can be by itself. And the way to get rid of it, since there's no sign to the left of b, that means that it's a positive. And the opposite of a positive is a negative. So we're going to subtract 6 from both sides. We're going to cancel out the 6. And then we have 5 minus 6. We're going to end up with a negative number. Negative 1 is equal to b. Okay, cool. Am I done? I figured out what b is. I can go away now. No, you can't, because your y-intercept is negative 1. That's when you figure it out. That's the first part. I guess you could say all of this was part 1 of the problem. And now you need to figure out part 2. Part 2 isn't that bad. You're just writing your equation using your y-intercept. So what that looks like, you're just substituting at that point. We know that our equation has to look like y is equal to mx plus b. We're starting with slope-intercept form again, right? And y is equal, we were replacing our slope with what we know our slope is. Our m becomes 3, which is why there's a y is equal to 3x plus b. And now that we've replaced it, we know what our b is now. We know that our b is negative 1. So we're going to replace our b with negative 1, and we're left with an equation. Y is equal to 3x minus 1. That is our equation. Our equation is now in slope-intercept form, and that's what the problem was asking. We are done here. Cool. Except we're not done. We need to be able to do this problem forwards and backwards, and no matter what kind of information they give us, we need to be able to solve for any piece of information as long as they give us something. This problem is an example of that. Okay, problem. Write each equation in slope-intercept form, then graph the line. Okay, so the instructions are a little different, and they give us our starting equation. Unlike the previous problem, right, where they gave us a slope and a coordinate point, and they asked us to create an equation. Here, they're saying we still need to create an equation, and we need to graph it. Last time we didn't graph it. Okay, so we're given an equation, and it happens to be in slope-intercept form, because if you're wondering how you determine if an equation is in slope-intercept form, it has to look like this, right? So does that original equation look like slope-intercept form? Well, we have a y, and the y is on the left side, and it equals an mx. We have a value for m. Our slope is 5, right? Because it says it in the equation. In the place where the m should be, we have a number 5, which means that our slope is 5, and we have a y-intercept, a b value of negative 4. So they gave us a lot of information there. They just did it in equation form. Okay, cool. So what am I supposed to do exactly? Well, you're supposed to graph it. Graph this line. Uh, we have a graph down there, but what you're going to want to do here is determine if this is in slope-intercept form. We did that already. Yes, it is in slope-intercept form. Cool. We can move on to step 2. If it's not in slope-intercept form, you need to solve for it. And I'm going to give you an example of that in the next slide. But for now, it is in slope-intercept form. We just move on straight to step 2. Step 2, write down what your slope and y-intercept are based on the positions of the numbers, right? So we've established that our m is 5, right? Because in the original equation, right, up here, we saw that y equals mx plus b, y equals 5x minus 4. The 5 is where the m was, so that means that that's our slope. So 5 is our slope, and b is our y-intercept. Okay, cool. Done with step 2. I've identified them. Now, step 3, we're going to graph the equation determining your first point using y-intercept. What did we say about y-intercept? If you look at our steps to graphing this, you know that your slope-intercept, if it's where your line meets the y-axis, so you will always have 0 for its x value, right? We're looking to make a coordinate point. And we know that if we're looking for a y-intercept, our x value is always going to be 0. And our y value would be our y-intercept. We know that our y-intercept in this case happens to be negative 4. So now we have our coordinate point, and we know where to start. Lucky for us, I already have a graph here, and I already graphed it for you. 0 minus 4. You always start in origin and you go down, because the -4 means that you're going down here, right? This is a -1, -2. That's a -3, and I don't have room, but that's a -4 down there. That's where that dot is, right? I know the graph isn't labeled, but you should be able to memorize where everything is, right? Just to give you context, uh, -1, -2, +1, +2. Okay, that should just be enough to give you context of where everything is. Okay, okay, so cool. So we have our first point. We're done? Well, not really. We need a minimum of 2 points to make a line, 3 points to show a pattern. Okay, so your equation says that a slope is +5, meaning that you have a rise or run of 5/1, or a rise of 5 spaces and a run of 1 space to the right. I know I says to the left. Sorry about that. I was supposed to say to the right. Then plot your next point. So we're going to start at 0, -4, and we're going to decide to go up. Okay, we have, because our slope is 5, that means that we have to rise 5, because 5 is positive, so we go up. So we go 1, 2, 3, 4, 5, and then our run happens to be 1. If you're wondering where the 1 came from, the 5 is a whole number, and to turn it into a fraction so that it's in the rise over run form, you just put a 1 under it. If it's already a fraction, you just keep the denominator. We went over 1. So we rose 5 spaces and we went to the right one. Um, if you have a negative number, instead of rising, you're going to go down by whatever the number is. You're going to go into the opposite direction, but you're still going to go to the right, right? The denominator is always going to go to the right. It's always going to run to the right. Um, the only exception for that is if you're working backwards. But so here, right, we moved on to that other point. This other point happens to be, let's see, +1 for my x and +1 for my y. Okay, now remember I said 2 points is a line, but 3 points is the actual pattern, right? So let's do another point. Let's go up another 5. 1, 2, 3, 4, 5. And then from here, we need to run 1 to the right, 1 to the right here. And then that gives me my next point, which is +2 and 6. Okay, and now that is my line. It's been graphed. The little squiggly lines are just my way of showing you guys that I counted. When you guys are showing your work, you don't necessarily have to draw the squiggly lines. You can if you want. I'll understand if you do. It helps some people. It doesn't for others. Um, that's optional, right? As far as labeling your coordinate points on the graph, I very much want you to label your coordinate points when you're showing your work. Please do that. Because it shows me that you know how to label coordinate points. And if you're having trouble with that, then we can always Zoom or you can always email me. Um, as far as your y-intercept goes, should you label your y-intercept? Sure. It's always nice to know that you guys know where everything is. So at this point, we've done what they asked us to do. We have our equation, right? We know that our equation is in slope-intercept form, and we graphed it. That's what the graph is for. So we're done, right? Yeah, but now we got to go over what happens if they give you an equation in standard form, right? And can you graph an equation in standard form? Well, the answer is yes, you can, but you need to turn it into slope-intercept form first before you graph. You cannot graph unless your equation is in slope-intercept form. Cool. So problem. Uh, 2x plus 6y is equal to 6. Hopefully that reminds you guys of this first slide right here. Ax plus by equals c, right? Because this problem is the exact same form. 2x plus 6y is equal to 6. Write an equation in slope-intercept form and then graph the line. Well, this is in standard form. We need to convert it into slope-intercept form. How do we do that? We start here. We start with just what they gave us. Step one, equation is not in slope-intercept form, so you need to change it by solving for y. So we need to solve for y. We use inverse operations, uh, and we move the 2x over. We're moving the 2x because we want the 6y to be by itself. So since there's no sign to the left of 2x, we're going to assume it's positive, and we're going to do the inverse operation, which means we're going to subtract 2x from both sides of the equation. This cancels out the 2x here, and we're left with 6y by itself on the left side of the equation is equal to uh, a minus 2x plus 6. Now, we cannot subtract a number with a variable from a regular number. So the 6 just kind of gets pushed to the side because the negative 2x is a higher power, right? It's more important than the 6, so it kind of just shoves the 6 to the side. It goes first, negative 2x plus 6. Okay, cool. Are we done? No, because our y is not isolated yet. Our y has a 6 attached to it. And when it's attached to it, we are multiplying, which means the opposite is dividing. So we divide by 6, but if we divide the left side by 6, we need to divide the right side by 6, which means we need to divide every single number by 6. Now, don't get confused, that x is attached to the 2, the negative 2. So when I divide by 6, I'm dividing negative 2x as a whole, as a term, divided by 6. And I'm dividing 6 by 6. Okay, that created two fractions there. So now I have y is equal to negative 2, 6, negative 2 divided by 6, x, plus 6 divided by 6. Now 6 divided by 6 is just going to be 1. So I simplified that, right? This became this. Step 4, since you divided by 6, you created a fraction. This fraction can be reduced, so simplified. But what I mean by reduce is we have negative 2 over 6. Because I can divide the top and the bottom by 2, I should. So it makes the equation a little more simple. Negative 2 divided by 2, right, is going to be negative 1. Divided by 6 divided by 2 is 3. That is my new slope, right? My m is negative 1/3, and my b is plus 1. This is my new equation right here. My equation is now in slope-intercept form. Given that I know that it's in slope-intercept form, I can determine that what m is, I can determine what b is. Then I can start by plotting my y-intercept. My y-intercept is going to be 0, 1. So I'm going to start in my graph now. I'm going to start at 0, 1. This is my y-intercept. Just going to abbreviate it there. At 0, 1. That's my how I start. Now my slope is a negative 1/3. Now this means that I'm going to rise, quote unquote, right, by negative 1, and I'm going to run to the right by 3. Now it's a negative 1, so I'm not actually going to go up. Instead, I'm going to go down by 1. And then I'm going to run 3 spaces to the right. 1, 2, 3. Okay, that's where I got that point. That point happens to be 3, 0. And then I'm going to do the same for the next one. I'm going to go down 1 more, and then I'm going to go to the right 3, which gives me to this point. This point is, from the looks of it, 6, 2. Yeah, this should be. Oh no, 6, 1. This is 6, 1. Sorry. Oh no, what happened? Okay. Anyways, let's just. Okay, I don't know what's going on. All right, there. This is supposed to be a 1, guys. Just all right. There, I graphed it. Cool. So am I done? Well, almost. We're almost there, guys. Determining solutions of equations in 2 variables. This is a word problem, And I'm just going to show you that for the word problems, it's all about your interpretation of the information, because you're just going to do the same step. Once you figure out what everything is, you're just going to do the same steps you've been doing, but the hard part is just interpreting. So the instructions: identify the slope and the y-intercept of the graph that represents each linear situation. Then interpret what they mean. Then write down the equation in the slope-intercept form and use it to solve the problem. So that's pretty much what I just said to do, and just in more complicated words. The problem says, for one taxi company, the cost in quote unquote Y dollars is a taxi ride is a linear function of distance X traveled in miles. That's a really fancy way of saying when you get into a taxi, they charge you by miles. The more miles you drive, the more they're going to charge you, right? The initial charge is $2.50, and the charge per mile, right? There's that key term again, per. The charge per mile is 35 cents. Find the cost of riding the distance of 10 miles. Okay, so how do I know they gave me a bunch of numbers, and I know I have to put those numbers into my equation, and I know I have to start my equation with slope-intercept form, but how do I know what's my slope and what's my y-intercept when they were talking about money, right? Well, every problem is going to have a different value. They're either going to be talking about money, distance, temperature, I don't know, whatever, right? They're going to be talking about different things, and it's your job to interpret what part of the problem is talking about slope, as in a change in 2 points, and which part is determining the starting point. The starting point is the y-intercept. If we put it in those terms, we realize that our starting point is the initial charge. Our starting point is $2.50, because when I get into that taxi cab, they're immediately charging me $2.50 just to get in, right? Then they're going to charge me per mile. For every mile they drive, they're going to charge me an additional 35 cents. And by the way, these rates are really old and outdated. Real taxis charge way more than this. Anyways, so the uh, the charge is per mile, right? So if I know that I'm going to do a distance of 10 miles, then I need to be able to plug that information in. So step one, just start off with the slope intercept form, write down the formula. Step two, remember that the rate of change is a way of saying slope. So my m is equal to 0.35, right? And your x is your distance, right? So they said that I'm going to travel 10 miles, so my x is 10, right? And how much they charge in the beginning is your y-intercept. Please ignore the various spelling errors in the step two. Anyways, moving on to step three. I just plugged them in. I substituted everything, nothing crazy. Y is equal to 0.35 times 10 plus 2.50. Cool. Now that I have them in there, I'm going to just multiply and I'm going to add. We're in step four, multiply miles times rate, and then add your two remaining numbers and calculate the final cost in Y. In this case, 0.35 times 10 is $3.50 for the actual ride, right? The amount of miles that we traveled, plus the $2.50 they're going to charge me for being in the taxi, for getting into the taxi. I add those two together, my total charge is $6, right? Which is really cheap. I don't even think you can get an Uber for that cheap, but all right. Um, cool. Last thing, I swear, creating an equation using 2 quarter points only. If you remember, I gave you the equation for the slope of a line. Like if we go back all the way to the beginning, I gave you this slope formula, right? And I showed you how to put them in, but I haven't talked about it yet. And the reason is that that is an entire other lesson in algebra, but we don't have time for it, so I'm just going to give it to you right now. Um, when you have 2 coordinate points, you can find the slope using the slope formula, right? And the slope formula is right here, right? M is equal to y2 minus y1, x over, right, divided by x2 minus x1. Now we have 3 minus 1, 3 minus 1. We need to create an equation that runs through these 2 points, and we need to decide which is going to be my x1 and my x2. I'm just going to go in order. My x1 and my y1 are the ones, x2 and y2 are going to be the 3 and the 3. You just need to assign x1 and y1 to one of the points, and the other point has to be your second point, which is x2 and y2. Okay, once you know what they are, replace them with what you see, subtract, and simplify, right? My slope is 1. Now that we found out that our final answer for that is 1, we know what our slope is. We know that our m value is positive 3, which means it's our rise over run, which means it's 3 over 1, positive 3 over 1, which means that from my starting point, I'm going to rise 3 and I'm going to run to the right 1 every single time. Okay, cool. Now I need to graph this, right? Now, we may not have the slope because we don't have an equation. Notice that we don't have an equation for these lines, right? So we need to actually create an equation. We need to find out what our y-intercept is. So we're going to do what we've been doing. We start with the slope intercept form, y equals mx plus b. Then we replace it with what we know. We know, and by the way, we have x1 and y1, we have x2 and y2, which means we have our xy value and we have our y value. Does it matter which coordinate point I decide to replace my x and my y with in my equation? No, it doesn't. You're gonna get the same answer each time as long if you did the equation correctly, right? If you solve for y intercept correctly, it doesn't matter if you use 1 and 1 or 3 and 3. Just pick one, and then just as long as you're using the entire coordinate point. So in this case, I chose 3 over 3 to represent my my x and my y, right? So x is equal to 3, y is equal to 3. In this case, my m is equal to 3. Uh, oh, I'm sorry. That my slope was supposed to be 1. Nope. Okay. Undo that. My slope was supposed to be 1. Yes, that's an m. Okay, so we have y becomes 3. We're right here now. Y becomes 3 is equal to m is 1, so I put it in parentheses. And then x we established was also 3. So that's going to be in 3 plus b. 3 times 1 is just 3. Isolate the variable, subtract 3 from both sides. We have 0. B is equal to 0. Is that weird? It's 100% allowed. It's not that weird. But you just need to recognize that your initial starting point, right, the y-intercept is going to be 0. And now the y value is 0, which means we actually start at origin in the coordinate plane. My y-intercept is 0, right? So we start there. And then, like I said, our slope is 1, which means that our okay, I just realized I wrote the wrong thing there. Undo that. Okay. Okay, so sorry about that. Right, so we're going to rise 1, and we're going to go to the right 1. Rise 1 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 to the right 1. Again, you don't have to do the squiggly lines if you don't like them. A lot of people don't. I personally like them. So there you go. That is my coordinate point. Did I need all those coordinate points? No, I really just needed the y-intercept, right? And I needed another point, maybe even 2 more points, right? For you guys, when you guys are doing the problems, unless they specifically tell you like, hey, graph 5 points or something, your minimum is 2 to 3, right? You you'll know you did it right if you can do a third point and it follows it still follows a straight line. So that's why I recommend 3 points personally, but that's what it is. All right, guys, good luck. Tell me if you guys need help, and I'll see you guys next time.